All right, so for Algebra 2, this is video number 2 for the week. Today we're going to talk about cube root functions. Again, you can work through these videos at your leisure, as quickly as you want or as slow as you want. But remember, if you have any questions about what we talked about in this video, we will be going over this in the Google Meets on Wednesday and Thursday this week. So if you have questions here, see me Wednesday or Thursday on Google Meet. I would love to see your faces. Don't forget also, Wednesday, we're going to do what's in the box. We'll talk about how that's going to look on Wednesday. So anyways, this is video number 2. So we're talking about cube root functions today. Remember, before we talked about square root functions. And within square root functions, we talked about the graph going up and to the right. We talked about the shifts that go along with it and what domain, range, and end behavior look like for that. Now we're talking about cube root functions. Okay? So cube root functions, first of all, the parent graph is no different. For the parent graph for square root functions, it was just f of x equals square root of x. Now for cube root functions, it's just f of x equals cube root of x. So no major difference there. It's the same function, it's just underneath a cube root versus underneath the square root. Now, let's talk a little bit about the difference. When we had square root of x, okay, when we had square root of x, if I made an xy table, if my x was 0, the square root of 0 is just 0. If I had an x of 1, the square root of 1 is just 1. Okay, then we talked about the fact that if I use things like 4, 9, and 16, if x was 4, that would be 2, square root of 4 is 2. If x was 9, square root of 9 would be 3. If x was 16, square root of 16 would be 4. Okay, we said that this graph only goes up and to the right in one direction because of the fact that you cannot have a negative x underneath the radical. If I tried to plug in negative 1, well, the square root of negative 1 is not possible. It's a imaginary number. You'd have to use imaginary numbers. We're not doing that right now. Okay, so this graph we said starts and goes up and to the right because of this. But when I get to a cube root of x, if I was to make an xy table for this, okay, sure, I could use 0, okay? The cube root of 0, 0 times 0 times 0 would be 0, right? I could also plug in 1, okay, because I can do the cube root of 1. 1 times 1 times 1 is still 1, okay? But I can also go in the negative direction. I could have the cube root of negative 1. If I plugged in negative 1 for x, well, the cube root of negative 1 is negative 1, right? Negative 1 multiplied 3 times is still negative 1. So it's possible for me to get negatives now. Okay, for example, if I did 8, okay, the cube root of 8 would be 2. The cube root of negative 8 would be negative 2. So how does this affect our graph? Okay, this is the parent graph. It really does not change much. It's a little bit flatter than the square root graph, but it doesn't change a whole lot. Okay? Our original square root function was up and to the right. Like I said, it's a little flatter, but it's still up and to the right. It still starts off at 0 and goes up and to the right. But now, because negative x values are possible, because it's possible to take the cube root of a negative, now I've also got the negative portion of this. Okay? It's going to go down and to the left as well. So in the parent function, it's going to go up and right and down and left. We're not worried about the specific points, but just because we wrote it in our chart, I mean, this is 0, 0. If I went over 1 and up 1, I would have the point 1, 1. If I went over 8, well, 2, 3, 4, 5, 6, 7, 8, and up 2, I would have this point, 8, 2. I would also have in the negative direction, negative 1, negative 1. Okay? I would also have in the negative direction, negative 2, 3, 4, 5, 6, 7, 8, and negative 2. Negative 8, negative 2. Okay? So that's what the parent graph for the cube root function looks like. Okay? It's going to go up and to the right, a little bit flatter, but up and to the right and down and to the left. It looks kind of like a flattened out S, right? Okay? Now, when we talk about shifts are still the same. So if I've got a cube root, okay, and x is underneath there. Remember, what happens underneath the radical will still shift it. Shifts the x coordinates. Okay? what happens out front or at the back outside of the radical still shifts the y coordinate. Okay? Not a whole lot different from square root graphs. Okay? We still have stretches, we still have slides, we still have shrinks, we still have flips. Not a major difference. Okay? Not a major difference. Okay, so that's kind of our overview. Let's do an example, and then we'll talk about a couple key characteristics that are a little bit different from a square root graph. Okay? So hopefully you've had a chance to write that down. If you don't, guess what? This is video now. You can rewind. Woo! All right? Isn't that nice? Okay? So let's say I've got this one that is y equals 1/2 cube root of x minus 5, okay, plus 2. Okay? Now, we still want to identify our shifts. So I'm still going to look. I'm going to say, hey, I got a 1/2 out front. I've got a minus 5 underneath the cube root. I got a plus 2 at the end. So I got 3 shifts. 3 shifts. Okay? The 1/2 out front. Well, it's out front, so that's affecting the y's. And since it's a 1/2, that is a shrink. Okay? Shrink. Well, I can't spell. So shrink, vertical. Okay? It's a vertical shrink. Instead of the graph being taller, it's going to shrink down smaller. Okay? And it's already flatter, so it's going to make it pretty flat. But we'll deal with that when we get there. Also, at the end, I've got a plus 2. That's going to be a vertical slide. Okay? In other words, I'm sliding up 2. Okay? Sliding up 2. And then underneath the radicals, same thing. Okay? It says minus 5. Normally, minus 5 we would think would slide us to the left 5, but in this case, we're going to slide right 5. So when I go to graph this, okay, remember, you don't have to do this, but if you can just envision in your head, great. But the original is going to kind of go up into the right and down into the left, right? And we're going to do our shifts. Remember, our cheat sheet here. We're always going to do slides first, okay? Then we're going to do shrink / stretch second, shrinks and stretches. Then we're going to do flips. Well, we ain't got none of them this time, so we can kind of avoid it. All right? So first things first, we're going to do our slides. There are 2 slides. I'm going to slide up 2 and right 5. So I'm going to go up 2, 1, 2, and right 5. 1, 2, 3, 4, 5. Up 2 and right 5. Okay, so now our middle is right there. Now, if you want to erase, okay, and then rewrite it, fine. I'm just going to rewrite it. Okay, now this is going up into the right and down into the left. It's doing the same thing it was before. It's just moved over 5 and up 2. If it helps you to get rid of the original, okay, so you can kind of see where you're at a little better, that's fine. Doesn't have to be perfect. We're looking for a generalization here. Okay, and then we need to shrink vertically. So the vertical shrink means it's going to kind of shrink it down, right? It's going to make everything less. Okay, what was 4, half of that would be 2, etc. So I'm going to keep this original, and all I'm doing is drawing it flatter. It's shrinking it. Okay, it's shrinking it. So it's taking what was here and it's flattening it out. Again, we are not looking for perfection right now. We're looking for a generalization of what is that final graph going to look like. It's going to look generally like this. Okay? We don't have any flips. If I had any flips, I could take this and flip it over the x or flip it over the y. We don't have that here. There were no negatives. Okay? I still need all of my key information. Vertex, domain, range, and end behavior. Right? Vertex is where the middle point is, in between the curve. Right? I'm over at 5, 2. Okay? So 5, 2. My domain, now here's the key difference. Okay? Within, and we wrote this before, within cube root graphs, okay, domain is always negative infinity to infinity. Okay, you'll see this on your homework today. It's one of the questions. Okay, domain, negative infinity to infinity. Always, no matter how I flip that, turn that, expand it, stretch it, shrink it, whatever, wherever I slide it to, it's always going to be going negative infinity. It's going forever to the left, positive infinity, forever to the right. Same thing with range. Even though it's flatter, and it doesn't look like it's going up or down much, it's still going up or down forever. So it's negative infinity to positive infinity. Okay, and then lastly, end behavior. Okay, end behavior now goes in both directions. So I've got to include both. So as the x's go towards infinity, what are the y's doing? As the x's go up towards infinity, or are going to the right towards infinity, the y's are going up. Y's are also going towards infinity. As the x's are going left towards negative infinity, you'll notice the y's are going slightly down towards negative infinity. Also, okay, remember we said if you need a little help on that, this graph in the coordinate plane, this is the positive x's and positive y's. This is the negative x's and positive y's. This is the negative x's and negative y's. And this is the positive x's and negative y's. So in this one, this part of the graph is going up. So the x's are going positive, y's are going positive. It's going towards here. Okay? This one's going down slowly, so it's going to end over here. The x's are going negative, y's are going negative. Okay? So if that helps you as a little bit of a cheat, great. Okay? So that's all for today. We're reviewing square roots Monday, Tuesday, cube roots Wednesday, Thursday. Next week we will hit some new stuff, but just review for this week. So now you're doing the second part of this review worksheet. Okay? Find the questions on Classroom. Okay? Don't forget, we are turning these in. We don't know exactly what grades will look like, but we need to somehow show your work and send that to me on Classroom. Whether you write it down, take a picture and send it, or whether you somehow do that electronically and send it in, I don't care. But so long as you show evidence that you are following along with what we're doing. All right? That's all for today. Don't forget, if you have questions, find me tomorrow or today, whatever it is, Wednesday, Thursday. Thanks.